Change is the only constant thing in this world. Do you agree to that? I hear some say yes, I notice some nods their head, and some are still unsure. Where, well, whether we like it or not, change is inevitable. Hindi natin yan maiiwasan. Especially in the field of astronomy. Good afternoon. Allow me to discuss with you the developments and diversity of the late 20th century, that is, from the period of 1970 to 1999. Astronomers realized that visible light only provides a limited view of the universe. So they began to explore the use of electromagnetic spectrum or the electromagnetic radiation. What are these? Radio waves, microwaves, X-rays, gamma rays, infrared, ultraviolet, and so on. Because of this electromagnetic radiation, it reveals the sun's corona, which is the outermost region of the sun. And due to atmospheric glaring, they began to upgrade their instruments, especially the telescopes. It became larger, and they also use adaptive optics to correct atmospheric glaring. This is also to allow astronomers to collect more data and observe minuscule or tiny objects.
So by now, let's proceed to the methods and observational astronomy. So astronomers use these types of messengers or signals to study the universe, which is the electromagnetic radiation, neutrinos, cosmic rays, or gravitational waves observation.
Observatories.
So multi-sensor astronomy, so this is observing a source using multiple methods. So, multi-messenger astronomy gives us more information about objects in space. It shows us that objects in space are not just objects we can see in the sky. It gives us a deeper understanding, but it gives us that they have properties and behaviors we don't know about. Okay, so let's proceed the important factors. So this includes the location for telescopes. The second one is light pollution. The third one is atmospheric turbulence. And the last one is technological solution. Let's proceed the measuring results. So astronomers use observational tools to measure celestial bodies and phenomena. So, examples of that like observational tools like telescopes and mga satellites. And precise measurements are crucial for objects close to Earth and distance stationary background. Early observation helps develop orbital models for planets like Uranus and Neptune. Erroneous assumptions like the existence of planets would manipulated corrected by Einstein and the general relativity. And part
Okay, now let's have the observational. So first we have here the telescope. The telescopes are the essential tools in observational astronomy for magnifying and gathering great light from distant celestial objects. So the telescopes, this is the very plays a crucial role in observing the light from distant celestial objects. And now next we have here the micrometer. So what is micrometer? Micrometer measures the angular distance between the stars using fine movable wires aligned with a telescope lens. So a micrometer, if a telescope measures the distance between the stars and the light objects on the then a micrometer is measured siya sa angular distance between the stars and nasa siya movable wires malugay siya and the telescope lens. So next we have a spectrograph. So the spectrograph is identifies specific wavelengths of light emitted by elements, allowing the study of the distant celestial bodies, and it has led to discoveries like helium in the sun and determination of the stellar temperatures and the radial velocities. So ang spectrograph which is a specific wavelength sa light na munikit siya sa elements, allowing the study of the distance from the celestial bodies. Okay, next we have the photoelectric photometry. So what is photoelectric photometry? Yet it uses CCDs to capture images down to individual photons for detailed spectrum analysis, and filters enhance image quality by isolating specific wavelengths and blocking unwanted light. So, by the way, what is CCDs? CCDs stands for the Charged Mobile Devices in the context of photoelectric photometry, and CCDs are used as the detectors to measure the brightness of the celestial objects, and such as the stars, galaxies, and also the asteroids. So next we have here the photography. Photography played a critical role in astronomy for over a century, but is now largely replaced by the electronic detectors like CCDs. So it's like the photography, this is the traditional na siya, but i-change na siya or na-innovate nga lang yung apuan, which is the CCDs. So na-represent na ang photography sa CCDs. And advantages include permanent images and the ability to track changes over time, such as supernovae. And next, we have the blade comparator. So a device for comparing two nearly identical photographs of the same sky section taken at different times, used to find changes such as the discovery of the variable stars or asteroids. So this blade comparator, this is the device to compare the near identical photographs in not the same time. So for example, if i-picture natin siya karon nga this morning, then picture na punta sa night, then i-compare mo siya. That is a use of the blade comparator. Next, we have the other instruments. Neutrino telescopes detect neutrinos from nuclear reactions and supernova explosions. Inaccessible to optical telescopes. Gravitational wave detectors identify events like neutron star collisions. Robotics spacecraft are employed for detailed planetary observations, bridging geology and meteorology with the astronomy.
By observing this, we have various techniques. First is experimental astronomy that determines the position or coordinate. Next is the magnitude. Mag-measure siya sa ka-brightness sa planet or whatever. Next is the relative brightness in spectrum to analyze temperature and physics of object. The P is parallax shift are used to measure distance to stars. Mag-measure din siya sa kalayo, kung sa kalayo ang stars sa awas na. C is radial velocity from proper motion measures. This star's relative velocity to the sun, instabilities in a star's atmospheres, or the physics of banyas. Next is mass of binary stars instead. P is observation of identical mass stars with cluster health in association age. The last is the observing galaxies and AGS involved, studying the overall shapes and properties of galaxies using standard candles, applying redshift surveys for galaxy evolution modeling, and that's all.